try to close my eyes, clear my mind, just listen to the wildflowers growing.
A dog's nose, 1,000 times more powerful than our own. Lingering smells allow dogs to peer into the past, and gentle breezes allow dogs to anticipate the future, say a beloved human about to come from around the corner. For most of us humans, smell, or for that matter, touch, hearing, and taste are not the primary senses we use to interpret the world. It's our vision that excels at detecting patterns and anomalies. Hence, it's our job as business analysts to ignite our stakeholders' visual senses with visuals that inform and persuade. For data visualization, there is a grammar of graphics that, once learned, helps us unleash the insights locked in our data frames. The grammar of graphics is an efficient language for you to describe how visual markings, like points, bars, and text, get placed on a screen. When done effectively, the insights from these markings jump off the screen and smack you and your audience right in the cerebral cortex. To see how to create insight-inducing visual markings, we get a cool data set about penguins collected by Dr. Kristen Gorman. The data set includes observations of 342 penguins, consisting of 3 species of penguins found in Antarctica at the Palmer Long-Term Ecological Research Area. The dataset is available in a package called Palmer Penguins. We use the install packages function to install the Palmer Penguins package, and then we comment out that line since we only need to run it once per computer. I could even delete that line, but I leave it in so that beginning collaborators are reminded of how to install the package. The library command gives us access to the dataset, and then we can look at it by just typing penguins and Control Enter to see the data. Since I don't want to be overwhelmed by all the columns in this really cool dataset and focus on visualizing this data, I will limit us to just 3 columns. And only after executing this line do I realize I'm using the select function and the chaining operator, both of which are part of the dplyr package. So let's add those back in and continue. Now looking at our 3-column data frame, we see some of the data is NA. I will filter to only keep the rows that are not NA. I use the is.na function, which returns true if there's an NA, and then I put the exclamation sign in front of it to say, I want not is NA, meaning there's a value. So this filter function keeps all rows where both bill length and bill depth are not NA. In other words, they have values. There's another way to look at this entire table of numbers. If we go up here in the upper right, we could click this little spreadsheet icon, and it brings up a spreadsheet view of the 3 columns of data: species, bill length, and bill depth. As we scroll through here, there's a lot of these Adeles, there's some Gentus, and chinstraps. There's 3 species in the data sets, and the bill lengths and bill depths look to be anywhere from 10 to 60 millimeters, something along those lines, and could be anything in there, it seems. It's hard for us to extract insight just by looking at a table of numbers. So what we learned today is how to map a particular column of data to a visual marking on a screen in such a way that the visualization is likely to yield insight for us. So we will learn to map species to a visual property. We'll call those properties aesthetics, and we'll also map bill length and bill depth to aesthetics. And in doing this mapping of aesthetics to data, and then specifying a visual marker which we want to use to visualize the data, we end up with a winning method of thinking about data visualization. This winning method is called the grammar of graphics. Closing this sheet, the grammar of graphics is implemented in R through the library ggplot2. To start a visualization using ggplot2, we use the ggplot function and we pass it one argument called data, and the value we pass to the data argument is our data frame. This is how we start a visualization using the grammar of graphics inside of R. So the GG and ggplot is for grammar of graphics. Pressing Control Enter, we get a blank slate. In the lower right-hand corner, the plots pane. Our goal now is to use the grammar of graphics to say how to put visual markings on this blank slate in such a way that we're likely to reveal insight from the data. So let's take an aside now and get introduced to the grammar of graphics. In the grammar of graphics, a visual marking is called a geom, short for geometric object. For example, a point is the name of a geom used to put a small circle on the page. In ggplot, all geoms are accessed using a geom underscore function, like geom underscore point. Every geom is associated with a set of aesthetics affecting its display. For points, the main two aesthetics are x, the horizontal position of the point, and y, the vertical position of the point. Other aesthetics include size, color, and shape. Another geom we will use frequently is the column geom. It shares the x and y aesthetics with geom point, but also has different aesthetics, like fill to change the color and width to change the width of the displayed column. Let's immediately put our lesson about geoms and aesthetics to work. Having initiated the ggplot function by supplying the data argument, we can now add additional layers and components to the plot. If you are thinking, let's use the chaining operator, I like your thinking. Unfortunately, ggplot uses a different operator, the plus sign, to string components together. So we use the plus sign and add our point geom. Notice geom point is also a function. Inside that function, I use another function, the AES function, short for aesthetic. All mappings from visual aesthetics of the geom point function to data inside of our data frame must be specified within the AES function. Our choice of mapping leads us to this scatter plot of build depth versus build length. Interestingly, it seems as the penguin's bill gets longer, the depth goes lower. Not what I'd imagine. I would think bigger penguins have both more length and more depth. Curious. So curious, in fact, that I think there's a problem. I think we have multiple species of penguins here. So let's map the color aesthetic to the species and see if that trend persists. Aha! I knew there was something fishy. We can now see that within a species, bill length and bill depth are positively correlated. One thing you might be tempted to do, or you might do by accident, is take one of these mappings of aesthetics outside of the AES function. When I do this and hunt for the species data, you'll see I get an error. However, if I want to map that aesthetic property to a constant, then I can do that outside of the AES function. Say a constant color of purple, or a constant size of 6, or a constant transparency level, known as alpha, of 0.4. Alpha can range from 0 to 1. And often when you have many points, reducing alpha closer to 0 allows you to see the overlap of the points. We're going to do two things. First, we're going to look up a geom on the ggplot cheat sheet to see what aesthetics it requires. And then we're going to create a data frame of new data, summary data, from our larger penguin data frame. Oftentimes, the data you need for a good visual needs to be created before passing the data frame to ggplot. Beginning users often look for a ggplot function to do summary statistics for them. But I encourage you to think about what visual mappings you want to create and ensuring that the data exists inside of the data frame that you're passing to the ggplot function. As we look through the ggplot cheat sheet, I can find geom line range. I'm going to press Ctrl-C and bring those minimum, actually it's not the minimum aesthetics, it's all the aesthetics that line range can take. And I'm going to bring them inside of my RStudio just so I can see them. The way to actually know which aesthetics are required and which are optional is to use the help documentation inside of RStudio. So we type the function name, highlight it, press function F1. This brings up the help documentation. As we scroll down, you will see a section named Aesthetics. The required aesthetics are bolded, in this case X, and then you provide Y min and Y max, or you can do Y and provide X min and X max. I'll demonstrate both. So the graph I want to create is, for each species, what is the smallest observed beak length and what is the largest observed beak length. While I know this data is somewhere contained in 342 observations, I actually have to create a new data frame, which I can then pass to the ggplot function. Inside of my summarize, I give the new columns meaningful names like max beak length and min beak length, and I use the aggregation function max and min, which are documented on the dplyr cheat sheet, to collapse my rows of 342 rows of penguins into just 3 rows, 1 row for each species, with a column containing min beak length and max beak length. Now we want to graph this data. We want to show the range of beak lengths that are observed for each of the 3 species. Geom line range is the perfect geom for indicating a range in a visual plot. For each line that we're going to graph, which is one of the 3 rows in the data frame you see in the bottom left, we're going to position the line along the x-axis according to the species value, and we're going to create a range starting at y min to y max for each of the 3 species for beak lengths. I'm going to up the size because my lines look pretty dinky, so I want some wider lines that are visible. And notice I can do the trick I alluded to before. I can change it so that the y-axis, or the y position, is my species, and x min to x max represent the range of possible beak lengths. To show you how you can layer plots in ggplot, let's go back and get the average beak length along with the min and the max beak lengths. And then we could use a point for the average beak length and put that point right on top of the line ranges that you see in the plot pane. That'll be a pretty cool graph. It shows a range of uncertainty in beak lengths, as well as the average beak length for each of the 3 species. Hopefully you're getting a feel now for how to map visual aesthetics to data locked inside of data frames. This is the grammar of graphics.
For each night the starlight and the sea together form eternity, and the wind moves like an echo as the world drops off to sleep.